Hey everyone, today I'm going to talk about AVL trees and node insertion. An AVL tree is a special type of binary search tree and it automatically keeps itself balanced after inserting or deleting nodes. The main advantage of AVL tree is the searching, inserting, and deleting data become faster and more efficient. The AVL tree was introduced by two scientists called George Anderson Welsky and Eugene Landis. Now let's talk about what is an AVL tree. An AVL tree is a self-balancing binary search tree. And in a binary search tree, the small values go to the left side and large values go to the right side. But sometimes a normal binary search tree becomes unbalanced. When that happens, searching becomes slower. Let's take these elements as example. 40, 60, 20, 30, 50, 10, and 70. When these elements are inserted into the binary search tree, 40 becomes the root node and 60 is greater than 40, so it goes to the right side of the 40. And 20 is smaller than 40, so it goes to the left side of the 40. And 30 is smaller than 40, so we go to the left, and 30 is greater than 20, so it goes to the uh, right of 20. And 50 is a greater than 40, so we go to the right side, and 50 is smaller than 60, so it goes to the left side of the 60. And 10 is smaller than 40, so we go to the left side, and 10 is smaller than 20, so it goes to the left side of the 20. And 70 is a greater than 40, so we go to the right side, and 70 is greater than 60, so it goes to the right side of the 60. So here we are all inserting the value in this order: 10, 20, 30, 40, 50, 60, and 70. Starting with 10, and it becomes the root node. Then 20 is greater than 10, so it goes to the right side. Next, 30 is greater than both 10 and 20, so it again goes to the right side. And this pattern continues all the values all the values. And this is what I want to say. The shape of the binary search tree or an AVL tree, depending on the order in which we insert the values. Even though the same values are used, different insertion orders can pursue completely different tree structures. In a normal binary search tree, this can lead to the unbalanced shape, making it look like a straight line in some cases. But in AVL tree, the structure is automatically adjusted after each insertion, so the tree balanced and efficient. Now I will explain something called the balance factor in AVL tree. The balance factor is used to check whether a tree is balanced or not. It is calculated using this formula. Balance factor equals height of left subtree minus height of right subtree. In an AVL tree, the balance factor should always be minus 1 or 0 or plus 1. If it becomes less than minus 1 or greater than plus 1, then the tree is not balanced and we need to fix it using rotations. Now let's understand this with a simple example. So here, 20 is the root node, and it has 10 on the left side and 30 on the right side. So the left subtree height is 1 and the right subtree height is also 1. Now we apply the formula. 1 minus 1, which is equal to 0. So this, this tree is perfectly balanced. Now let's look at another example. We have this structure. 10 goes to the root, and 20 goes to the right, and 30 also goes to the right. So here the left side has height is 0, and right side height is 2. Now the balance factor is 0 minus 2, which is minus 2. Since minus 2 is less than minus 1, this tree is not this tree is unbalanced. So in this case, an AVL tree would perform the rotation to make it balanced again. Now I will explain how node insertion work in AVL tree. Insertion in AVL tree start just like the normal binary search tree. First, we compare the new value with the root node. If the value is smaller, we move to the left side. If the value is larger, we move to the right side. We keep doing this until we find the correct empty position and then we insert the node there. After inserting the node, the important step begins. That means we check the balance factor of each node starting from the uh, inserted node and moving up to the root. If the balance factor within the minus 1, 0, plus 1, then the tree is still balanced and nothing need to be done. But if the node becomes unbalanced, then we perform the rotation to fix the structure of the tree. So the most important part of AVL in a AVL insertion is not just inserting the nodes, but making sure the tree stays balanced after every insertion. Now I will explain rotation in AVL tree. Rotation is a special operation used to restore balance when the tree become unbalanced after the insertion or deletion. In an AVL tree, there are four main type of rotations. The first is a left rotation, the second is right rotation, the third is left right rotation, and the fourth is right left rotation. Each rotation is used depending on where the imbalance happen in the tree. The main idea of rotation is to rearrange the nodes in a different structure, but still follow the rule of binary search tree. So even after rotation, the small values stay on the left side and the large value stays on the right side. By using this rotation, the AVL tree keeps itself balanced and ensure fast operations like searching, inserting, and deleting. Now I will explain the right rotation in AVL trees. The rotation is used in a left-left case where the tree become unbalanced by growing too much on the left side of a node. Let's look at the example before rotation. We have 30 as the root node, 20 is the left child of 30, and 10 is the left child of 20. So, the tree look like a straight line on the left side, which make it unbalanced. Now we perform the right rotation. After the rotation, the middle node, which is 20, move up and become new root, and 30 become the right child of 20, and the 10 stay as the left child of 20. So the new balance tree is 20 as the root, 10 on the left, and the 30 on the right. Now the tree is balanced again. The main idea of right rotation is that it moves the middle node upward and reduce the height of the left heavy structures. Now I will explain left rotation in AVL tree. This rotation is used in right case where the tree become unbalanced by growing too much on the right side. Let's take this example. We insert the value 10, 20, and 30. First, 10 becomes the root node, then 20 is greater than 10, so it goes to the right. Next, 30 is greater than both 10 and 20, so it also goes to the right side. Before rotation, the tree looked like this: 10 at 10 at top, 20 on the right, and 30 again on the right side. So the tree becomes unbalanced because all nodes are on the one side. Now, AVL tree perform a left rotation. After the left rotation, 20 move upward and become the new root node, and the 10 become the left child, and the 30 becomes the right child. Now the tree is balanced again. So the purpose of the left rotation is reduce the height of the right heavy trees and make the structure balanced. Now let's look at how we fix this right-left case. Before rotation, the tree look like this. 10 is the root node and the 30 is on the right side of 10 and 20 is on the left side of 30. So this creates a zigzag shape, which is called a right-left imbalance. Now we need to fix this using two steps. First, we perform right rotation on node 30. This brings 20 up and move 30 down to right side. Now the structure becomes the straight line like 10, 20 and 30. Next, we perform left rotation on node 30, node 10. This moves 20 up to become the new root node. And finally, 10 becomes the left side and the 30 becomes the right side. So the tree become balanced again with 20 as the rule. Now I will explain left right case in AVL tree. We insert the value 30, 10 and 20. First 30 become the root node and then 10 is smaller than 30 so it goes to the left side. Next 20 is smaller than 30 but greater than 10 so it goes to the right side of 10. So the tree form a zigzag shape, so which is called a left right case. Before rotation it look like this. The 30 is in the top and 10 is on the left and the 20 is on the right side of 10. Now we need to balance it using two rotations. First, we perform a left rotation on node 10, which brings 20 up and moves 10 down. After that, the tree becomes a straight line. So next, we perform a right rotation on node 30, which makes uh, 20, 20 the new root, and the finally 10 becomes the left child and 30 becomes the right child. Now the tree is balanced again with the 20 as the root. Finally, AVL trees are an important improvement over normal binary search trees, and they help keep the tree balanced after every insertion or deletion, which makes operation like searching, inserting, and deleting much faster and more efficient. The main idea of AVL tree is simple. Whenever the tree becomes unbalanced, it automatically corrected using rotations. In this video, I explained the structure of AVL trees and how insertion works and how the balance factor is calculated and how different type of rotations are used to maintain balance. So, overall, the AVL trees ensure that the tree always stay balanced, which improves the performance and prevent the tree from becoming too tall and inefficient. And thank you for watching my video.